Hi folks, welcome to this video on nitpicking simplification of derivatives. So often there are many different ways to present an answer, and your way may be a little bit different from the back of the book and you want to check and see if they're equivalent, or maybe you want to convert your way into what they have in the book or vice versa. When we want to simplify derivatives from the product and quotient rules, we tend to use greatest common factors if we can. This is especially true when dealing with fractional and negative exponents. So early on in the course, we were called common factoring. We expanded our idea of common factors and said it's just the lowest power that you find on any of the single terms in the function. So in this case, it's going to be x to the 3 over 2 as a common factor. And the powers will go down. This will go down by 3 over 2 and become x to the 4 over 2. And you probably just want to call x to the 4 over 2 2. And this one will be 3x to the 2 over 2, or 3x to the 1. And it'll be all gone from this term. By doing that, you can factor further. And that may be helpful for us later on. Often we're going to be interested in the zeros of a derivative. Similarly, in this other one, the lowest power that we see in any given term is x to the negative a half. And that's going to give us 1 here. And the other one, since we took out a negative power common factor, power is going to go up by a half. Now you can always check by multiplying back in, but that's a correct factorization. And it helps us see that there's an answer in this one of -1 if you were to set it equal to 0. So it follows that if you have something like this, that really there is a common factor that you can take out. You can take out x to the negative a half because they have x's out front. And when you do that, let's see what we get. X to the negative a half comes out, so we're ended up with 2x minus 3 plus the power on this one right here will go up by 1. So it becomes x by x plus 1. I think in the other form, factoring it was going to be hard. Even putting it with a common denominator was probably going to be annoying. This is also going to help with making common denominators. So I'll have 2x minus 3 plus x squared plus x in these brackets, or x to the negative a half by x squared plus 3x minus 3, which is not factorable further. If in the end what you want to do is convert this into a fraction over a common denominator, actually, greatest common factors do that job for you. You can just make that all over. X to the negative a half is just a root x in the bottom. So having a sort of expanded idea of how to get a greatest common factor can help us express things in different ways and can end up giving us an easier path to, say, elegant ways of expressing stuff. Often this is not an issue, but we do need to be able to figure out whether our unsimplified answers are equivalent to any expressions that are in the book. We also just value elegance in answers. So here is one. Here's one that's going to involve the product rule because it has a first part of 2x to the half. And so we're going to have to find the derivative of that. And it has a second part of x squared plus 3x. Okay, so what we're going to show is that the derivative can be written in this nice pretty form, which it probably won't be when we first get into it. All right, so what does that mean we get for a derivative? Well, we'd have 2 times a half x to the negative a half, or that's just x to the negative a half. Let's just write it that way. V prime is 2x plus 3. So the derivative, let's make this part equal to y. Y prime is going to be u prime v plus u v prime. There's our product rule. And right away you can see that there is a greatest common factor of x to the negative a half. There are really only two terms here. There's this term and this big term. So let's take stuff out. That would leave us with x squared plus 3x plus 2. This term right here, its power is going to go up by a half because we took out a negative power common factor. And from here, I can just kind of plug and chug. X to the negative a half. Then I'll have x squared plus 3x plus 4x squared plus 6x. Now, some people might have early on recognized a different common factor or yet another one. That's fine. I think this is going to get us there, though. So we have, in brackets, 5x squared plus 9x. Things are looking somewhat close here. I might notice in those brackets I have another common factor of x. So I could multiply that out, or take it out rather. And then I have x to the negative a half times x to the 1. So I add the exponents. Gives me x to the 1/2, 5x plus 9. If all you needed was an answer, was this stage okay? Absolutely. If what you want is an elegant answer, then this is probably good. And if you want something that's multiplied in, well, you could multiply that x to the half in for each of those terms. But it's nice and factored like this, and it did ask us in this question to show how we get from one stage to the other. This will also come up if we're looking at quotient rules. So we really don't want negative exponents in the end in a quotient rule. So in this one, I mean, my u is 2 root x. That's the same as we had up here. So we've already established that u prime is going to be x to the negative 1/2. The bottom here, v is 5x minus 1. And v prime is just going to be 5. And let's make this y, this whole function here. So we're going to say y prime is equal to u prime v minus u v prime all over v squared. And on top, again, there are really just two terms. So I'm going to take out that x to the negative a half. That will leave me with 5x minus 1 minus 2x times 5. And it's an x now because I took out the x to the negative a half from this term, so the power goes up by a half. And on the bottom, I have 5x minus 1 all squared. I can leave that x to the minus a half out here. In the brackets, I have 5x minus 1 minus 10x all over 5x squared, or 5x minus 1 all squared. Or I have this, x to the negative a half by negative 5x minus 1. And that'll be 5x minus 1 all squared on the bottom. That's almost there, but I really hate that x to the negative a half. Since it's factored out, though, you can do stuff safely. You can cancel if you had stuff to cancel out, but you can also just move. So this will become root x, 5x minus 1 all squared on the bottom, and negative 5x minus 1. You get an elegant expression for the derivative, rather than this messy business over here. This doesn't come up a whole ton, but I think it's important that we take a second just to recognize that there are often many ways of presenting an answer, and some are going to be more elegant than others. I hope you found this helpful. Good luck with the material, folks, and take care.